We're going to talk about dividing a decimal by a whole number. And we are going to use partial quotients to solve this. So this is different than the typical long division algorithm that a lot of people have grown up with. This is something that is taught more now. So I want to look at 3 9/10 or 3.9 divided by 3. So what I'm going to do is start by setting up my problem. So I have my division symbol, and I put 3.9, which is my dividend. So I put my dividend inside and the divisor, which is the second number, on the outside. Then for partial quotients, I need to do this, set up this partial quotients line. It's just what we do to separate the number of times I've multiplied by 3 versus what I'm taking out of my dividend, and that'll make more sense in a minute. So my problem is now set up. I'm going to start by making myself a table. Technically, you don't have to do this. I think it makes it easier for a lot of kids to not have to figure out the multiplication of this number over and over. Most kids can figure out their 1 times tables, 2 times tables, and 5 times tables. So I'm going to start by figuring out 1 times 3 is 3, 2 times 3 is 6, and 3 times 5 is 15. I'm going to go ahead and do another line. And in this next line, I'm just going to add a 0 to what I multiplied 3 by, which means I just have to add a 0 to my answer. So 10 times 3 is 30. 20 times 3 is 60. You can see I'm just adding a 0. And 50 times 3 is 150. I don't need to go any further than that. So I'm going to start by looking at my dividend, which is on the inside, and I'm going to ignore the decimal for now. We will come back to it at the end, but for now I'm going to ignore it. So I'm going to look at this, what is 3 9/10. I'm going to look at it like it's 39. So I need to figure out what I can take away, how many groups of 3 I can take away from 39. So I'm going to look over at my table and try and find the biggest number in my table that gets me, without going over, that gets me close to 39. So 30 is the biggest number I can take away. So I am doing 3 times 10. So I'm taking away 10 groups of 3, and that's 30. So now I just subtract. 9 minus 0 is 9. 3 minus 3 is 0. So I'm going to look at the next closest number in my table, which is 6. So I'm going to take away 6. Now you might, and to get 6, I did 2 times 3, so 2 groups of 3. You might notice, if you know your 3 multiplication tables, you might notice that I could just take away 3 groups of 3, take away all 9. If you know your multiplication tables and you can do that, that is perfectly acceptable. But if you don't, it's okay. It'll just take another step, and that's not a big deal. So I took away 2 groups of 3. I ended up with 3 left. Now the closest number to 3 should be pretty obvious. 3. I can take away 1 group of 3, so I need to write that on the right. And 1 times 3 is 3. I end up with 0, so I have no remainder, which is great. So now for my answer, I need to add up how many groups of 3 I took away. So I will do 10 plus 2 plus 1. We start by adding the 1, so 0 plus 2 plus 1 is 3. And then 1 plus nothing is 1. So I'm going to write 13 up here on my answer line. Now, to figure out where to put my decimal, I just need to count how many numbers are behind the decimal in the dividend? Well, I have one number behind my decimal, so I need one number behind my decimal. You can do it with an arrow, you can underline it, whatever is going to help you figure out where to put your decimal. Sometimes I just underline how many numbers I have after the decimal. I have 1, so I would just underline 1 and put the decimal next to that. Whatever works for you. I'm trying to erase my arrow now, and I can't do it. That's okay. So the answer is 1 3/10, or 1.3. There you go. I actually want to show you one more just for a little more practice. Let's do a bigger number. So let's take 23 and 261 thousandths divided by 7 wholes. This is bigger than any of the numbers we did in class today, and so it's good practice. So I'll start by setting up the problem. I'm going to put the dividend inside and the divisor on the outside, and then I'll draw my partial quotients line. I'm going to do a table with 1 times 7, 2 times 7, and 5 times 7. So 1 times 7 is 7, 2 times 7 is 14, and 5 times 7 is 35. Now for my next line, I am going to do 10 times 7, 20 times 7, and 50 times 7. So 10 times 7 is 70. 20 times 7 is, I'm just adding a 0, 140. 50 times 7 is 350. I'm going to go another line because I'm going to get as close to 23,000 as possible. Remember, I'm ignoring the decimal over here, so I could just cross it out. I'm just ignoring that decimal for now. So I'm going to look at it as 23,000. I need to get as close to that as possible. So 100 times 7 is 700. 200 times 7 is 1,400. And 500 times 7 is 3,500. Again, I'm not there yet, so I'm going to add another 0. 1,000 times 7 is 7,000. 2,000 times 7 is, I'm just going to add a 0, so I should have 3 zeros, 14,000. Not there yet, but I'm getting close. 5,000 times 7 is, well, I'm just going to add another 0. 35,000, that's too big. I don't need that number. So now I'm going to try and find the biggest number from my table that gets me close to 23,000, because remember, right now I'm just pretending like this is a comma. I'm kind of ignoring that decimal. So 14,000 is as big as I can go to get me close to 23,000. So I'm taking away 14,000. And to get 14,000, that's 2,000 groups of 7. So I'm subtracting that 14,000. 1 minus 0 is 1. 6 minus 0 is 6. 2 minus 0 is 2. I cannot take 4 away from 3, so I'm going to have to regroup. 13 minus 4 is 9, and 1 minus 1 is 0. All right, now I have 9,261. The closest I can get to that is now 7,000. So I'm going to take away 1,000 groups of 7, which is 7,000. I guess I could write a comma up there. 1 minus 0 is 1. 6 minus 0 is 6. 2 minus 0 is 2. 9 minus 7 is 2. So now I have 2,261 left. Well, 7,000 is too big. 3,500 is too big. So I can take away 1,400, which is 200 groups of 7. So 1 minus 0 is 1. 6 minus 0 is 6. I cannot take 4 away from 2. So if you think about having 2 fingers, if I have 2 fingers up, I can't take 4 fingers away. So I'm going to regroup. So I'm change that to a 1, change this to 12. 12 minus 4 is 8. And 1 minus 1 is 0. Okay, now 1400 is going to be too big to take away from 861. So I can take away 700, which is 100 groups of 7. 1 minus 0 is 1. 6 minus 0 is 6. And 8 minus 7 is 1. So I have 161 left. 700 is too big. 350 is too big. So I can take away 140, which is 20 groups of 7. So you can see I actually have that written down on my table, which is why that table is so nice. Then I just subtract. 1 minus 0 is 1. 6 minus 4 is 2. And 1 minus 1 is 0. Now I have 21 left. You might notice, if you know your 7 times tables, and I'm actually going to do it this way this time. If you know your 7 times tables, you know 7 times 3 is 21. And 21 is what I have right here. So I can just take away 3 groups of 7. 3 times 7 is 21. And end up with 0 left. Now, if you didn't recognize that, it's okay to take 14 away, 2 groups, and then 1 group of 7. You'll get the same answer in the end. This way just is a faster way to get there. Now I'm going to add up all of the number of groups I've taken away. So I have 2,000 plus 1,000. You'll see I'm rewriting this off to the side. The reason I'm doing that is so that I can make sure my place values are all lined up. When we're adding, remember it's important to line up the place values. All right, so I'm adding all of these numbers. So 0 plus 0 plus 0 plus 0 plus 0 plus 3 is 3. 0 plus 0 plus 0 plus 0 plus 2 is 2. 0 plus 0 plus 2 plus 1 is 3. And 2 plus 1 is 3 as well. So up on my answer line, I'm going to write 3, 3, 2, 3. Now, I'm not done. It doesn't make sense that 7 can go into 23 3,000 times. That makes no sense. So stop and think about your answer and say, does this make sense? No, unless I add my decimal where it's supposed to be. Then it will make sense. So I have 1, 2, 3 numbers after my decimal. You could even go back to your original and say 1, 2, 3. You have 3 numbers after your decimal. So I need 1, 2, 3 numbers after my decimal. So I'm going to place the decimal right before those 3 numbers. So my answer is 3 and 323 thousandths. Now, if I wanted to check my answer, which is a good idea, I won't go through it right now, but I could go 3 and 323 thousandths times 7, and that should give me 23 and 261 thousandths.